good. Everything sounds good. This is a recap of one that we did back in, I think it was January, February, and we had some technical difficulties and could not get the everything to work and get it recorded. So Todd had asked us to do it again. What we've done is we've taken the original webinar that we did and we tried to integrate a lot of the questions that we had from the first one into the webinar, and we've left some time hopefully at the end to do some more questions and answers and a few demos as we go through here. So what we're going to do is we're going to show you the basic way that we measure and how we've evolved from the day one to what we're actually doing now. And it's quite an evolution to get where we got to. But we'll start a little bit about our primary thoughts. I come from a machine shop background, so machine shop background, everything's on the print. You just make it as a print, and if it's not correct, it's the guy in the upstairs office's fault. So that's the basic premise that my brain comes from. So we started with the first premise: if we can increase the field measures to ultimately reduce shop rework and expensive time in the field. What we saw originally was we were having a lot of errors out in the shop around the field, and they were caused by, a certain amount of them were caused by measurements out front and our CAD drawings. So we set on the task of trying to get the measurements, CAD drawings correct, so the people in the field and the people in the shop could make what they needed to make, and we didn't have as much time problems. Secondly, we opened up the Caribbean as a market, and we knew we were going to travel, so we got to the point where we wanted to make sure we could try to do as much of it with only one person as we could. And that was a driving force for us, and most of the things you're going to see here, we've gone all the way from tape measures to e-templates. So you can see what was driving it is we were trying to get to the point where we didn't have to send two people or send fabricators to the field. And then we always wanted to try and integrate new technology as we go along. What we're going to do is we're going to start you all the way from start to finish. Some of you have seen a little bit of this before, but we're going to go through it quickly, and then we're going to get into a little bit more of the meat of the presentation later and some of the demos. But what we do is when we start with blueprint measurements, J.R. Molina from Big D Metalworks got us onto Bluebeam PDF to do takeoffs. Naturally, everybody's trying to push takeoffs, the architects and everybody's trying to push it down to us to try and do it. You get 60 pages of prints, and you need to do takeoffs. And what you're seeing right now is a takeoff on Bluebeam. Everything you see in red and blue was done on Bluebeam. Bluebeam's about $175 to $190 program. It's relatively cheap and inexpensive. With Bluebeam, you have the ability to, if your drawing comes in, say at a 1/4 inch scale, you can key in 1/4 inch scale, and then you can scale all your measurements from that point. It also has the ability, if you get a drawing in that does not have a scale on it, as long as there's any dimension anywhere on that drawing, you can actually calibrate Bluebeam to whatever that dimension is. So in other words, if I had a dimension right here that I knew what it was, I would set Bluebeam to measure from there to there, and then I would tell it how long that measurement was, and it would automatically calculate itself from that point on. And with Bluebeam, you have the ability to measure lengths, angles, radius, diameters, a lot of different types of measurements. And it also will give you a running list at the bottom of your screen. If you want to print out the list of what the measurements were at the bottom, you can, but we've not chosen to do that yet. It also has the ability inside AutoCAD to do batch plotting for you if you buy the AutoCAD version of Bluebeam. Some of the other things we find useful with Bluebeam is I don't like to sketch a lot, so I'll take a lot of pictures. So what I've started doing when I've got little details is I'll stick a tape measure in front of the details. If for some reason I need to go back and catch one of those measurements later, I can go to Bluebeam. As long as I've got a fixed measure somewhere in that picture, I can use Bluebeam to say, okay, from this point at 31 inches at 26 inches is 5 inches. I tell Bluebeam that's 5, and then I can start measuring whatever I want down. We use that quite a bit, especially if we're replicating something. For example, this piece right here, we've got a fixed measure, so we can come in and get some measures. They may not be completely accurate, but they're going to be pretty close to what you need. Same thing with that. The thing you've got to watch out for is your camera takes kind of a distorted view. So the wider you get, the less accuracy you get with that. We'll quickly go through the measurement tools that we use, starting with straight measures. These are pretty straightforward. Probably the one that nobody thinks about are these down here in this lower area, these seamstress tape measures. It's probably one of the most useful we have. We wrap them around columns to see how big a column is, see the circumference column. We tie them onto a rail like you saw in the last one. You can just tie them up and you can got dimensions. You can take pictures in front of that. Nice, useful item. We carry two different smart levels, a 24 and a 48, and also a small angle cube that you see up in this picture. This is going to be real handy when we're traveling. If we're going to the Bahamas or out in the Caribbean, we don't want to carry our smart levels with us. We throw that little angle cube in, and it does basically the same thing the smart level does. We carry a Bosch electronic protractor. Usually we carry it out in the field, and there's always one in the shop. We also have come up with what we call a straight edge. We took two pieces 48-inch long, a 1x2 tube, and put a seam section in between them, and we can put them together and get an 8-foot run. We use this especially useful when you've got that stair nosing or stair tread that's kind of wobbling on you. With some surveyor clamps, we can get up above that stair and we can get a little bit more accurate measurement of the stair. But then again, you can see how easily that angle gauge is when you come to it. Next, we use Bosch square laser. The laser down in here, if you're trying to get a square laser both in the field or in the shop, you can get a 90-degree beam line on both of them. It's a real inexpensive product. We use a Porter Cable single laser, and since Mark O'Malley's education session in metal fab, I've switched to a Bosch 5-line laser, which is coming in very handy. It also comes with a pouch, so you can attach it to your belt and pull it right out of your belt. We don't, since I've got the 5-line laser, we don't travel much with the rotary laser as we used to, but we'll take the rotary laser. It gives us X and Y direction, both up and down, both at the same times. One of the nice things we like about it is we can put it in dither mode, and dither mode gives you a line of about only 6 to 12 inches wide, and it brightens the line. So if you're in a place where you're having a little trouble seeing a line, you can throw it in dither mode. With the remote control, you can move it around and rotate it to get it to the position you want, and you get a little bit better perspective of the line that you're after. These items are laser distance meters. These were a pretty hot topic about 4 or 5 months ago on listserv. Starting in a metal fab education session about 6 or 7 years ago, we saw a Hilti unit, which is a much larger unit, and we purchased this Hilti PD30 right after that. It's a small handheld unit. It does a phenomenal job, and we ended up buying about 3 of them. We had every salesperson plus the field people all had Hilti units because they go out and do a sales call. In many cases, we just have them pull some of the measurements while they were there. The one on the right is a new disto unit that we bought about a year ago. There again, this one was recommended to me by Mark O'Malley. This happens to be a disto 8. You'll notice that both units, both sides, hold the last 4 measurements that you take. You can use the front or the back of the unit to take measures. If you're taking something from, say, from a balcony down, you can use this end of the unit and switch it to that end. If you're taking normal measures, you typically use the back. Both of them have that ability. Both have the ability, they have a little pop-out gauge that pops out of the bottom of it if you want to take a measurement inside a corner. Say if you're trying to do a square measurement of a room from one corner to the next corner, or you're trying to do a measurement of a door. Those are real handy. And also the D8, the Leica unit, also bends on around and you get a 90 degrees, so you can hook it onto the side of a balcony or whatever you want to measure to. Actually, the only difference between these units, there are a number of other units like Bosch and Stanley, but these we see as some of the top of the line. The primary accuracy that you'll see is, primary items you'll see is the accuracy and the range are virtually identical, and they pretty much hold that accuracy. The difference between the units, the primary difference, the PD30 has no tilt measurement, whereas the Leica D5 has a plus or minus 40-degree measurement, and the Leica D8 can measure in 360-degree intervals, all the way around any way you want to turn it. Those are the primary differences in it. And also, the LTPD30 does not have a display, and we'll show you that display in a minute. You'll notice the Leica both have video and photo displays, which is one of the primary reasons why we bought the Leicas. You'll notice it has from 1 to 4 magnification. If you get to a point where you can't see out in the sunlight, is probably the most important place you'll use that. You can mount them on a tripod. If you have a little, as we get a little older, we start shaking a little bit. You'll notice that it also has the ability to a timer function where you can set it on a tripod, or you can hold it in your hand. And it's much easier to use in your hand with a timer because you're not trying to push a button each time. And these will take, both the units will take dynamic measures. In other words, you want to measure from one end of the wall to a top end of a wall. It will calculate from where it's at, from the bottom of the wall to the top wall, tell you the height of the wall and what your angle was at the time. This one, they have more bells and whistles, and I still haven't figured out how to use all these things. But extremely accurate, extremely important, and with these have been one of the primary reasons we've been able to do it with just one person out in the field. You notice the dot where my finger's at, and you'll see in the upper left-hand corner, you can see where the photo is telling me it's at too. Sidewinder, this has been used for quite a few years. It's a unit that you can, with these basic clamps, they come in a lot of different lengths. The basic clamps, you can clamp it in place, and what we would typically use a Sidewinder for is we clamp it in place and we take it down and scribe onto a board or onto a piece of dirt rock or whatever we had available that we could scribe a curve to, and that way we could take it back to the shop and we already had the curve. Nice handy little unit, but I would tell you this is a 4-foot unit, and if you get much more than 4 foot, it's like holding onto a snake. It gets really difficult. You almost need 2 people to do that. Any questions on the equipment or anything we do before we get into the procedures? Okay, let's talk about documentation procedures. This is something that we did not hit very hard in the last one, which we feel is probably a very important issue. You'll see this happens to be a sheet that Mark O'Malley showed at the Metal Fab in Orlando. A really, really good sheet for measuring stairs. It shows all his documentation, all his numbers that he needs, and it works both as a checklist. It's discouraging to go out and measure a set of stairs or something, or a door or whatever, and come to find out you missed a measure. So this does 2 things. Gives you a template to write on, and it also works as a checklist. So I would highly encourage, we have these for doors and a few other things, so I highly encourage anybody to use this type of checklist and make one up for your own, or contact Mark and he may share that with you. Our philosophy has always been, we've had in-house detailers. We also have a detailer in Sweden that does work for us, and a couple others, that we try to give them pictures along with the dimensions. So we went through a period of time where we would go out and take pictures, and then we would come back and we would print the pictures and then write dimensions on the pictures. The Leica units, the D5 will run somewhere around $500, $599. The D8 runs around $699 to $700, but you can get those a lot cheaper. There's a couple places where they don't advertise the price, but you can get a quote from them and get a cheaper price. So the D5 you can probably get down around the $400 range, and the D8 you're going to get around the $590 to $600 range typically. The PD30 has now gotten up around $400 range, but you can get some of them on eBay if you're looking for that. The thing I found out when we bought the PD30, we pretty much paid for the price of it within about 2 months, just for the sheer fact of not having to send 2 people out sometimes. Okay. Here's another example of where we would look at something and say, okay, let's just put the measurements on the pictures. So the detailer and the installer, anybody that can pull up later, they can see the measurements. And you notice that's my handwriting. It's not real good at handwriting, so that presented a little bit of problem, which led us to a couple of the ones you're going to find next. This is an example. We went to the Bahamas and measured a wood stair for a woodworking company that's going to make the stair treads for them. And what we did, one of the things I hate to do, I hate sketching in the field. It takes time and I'm not that good at it. So what we do, the first thing we do is we start taking pictures with a digital camera. In this case, what I did, I went ahead and sketched it, and then when I got back to the office, I used Bluebeam, and I went ahead and added all the dimensions, all the numbers you see in Bluebeam. This particular example, this was going off to North Carolina, so no, it wasn't anybody I could stand in front of them and explain it to. So I had to make sure I had everything documented accurately and easy to understand. And you'll notice I've also all figured in what his angle degree and what the rise and run is of the entire stair is. And this took about 15 minutes to do about 5 pictures in Bluebeam to get to this level. It also gives you the opportunity with your camera to come in and say, okay, here are issues you need to watch out for. Issues where a measurement is one place, but they're going to add something onto it, something you're going to convey to somebody that you don't necessarily, if you're not in the office or you're not handy to get, you've conveyed pretty much all of it. Plus, they also can see the picture at the same time. Next, Mark O'Malley again in the education session got me onto iPhone apps that can do measuring. And I'll show you the one I think Mark was using before is MyMeasure Pro. The one I'm using now is Photo Measure, so both iPhone and iPad capable. Both of them are about around $5 apps. And you'll see that I use it on an iPad because I think an iPhone is just a little small for me, but an iPad works really pretty well. The first thing you do, you can do one of two things. You can go through with your digital camera and you can take digital pictures of it, and then you can import them into your iPad or iPhone, or you can use your iPad or iPhone to take the picture for you. But you notice we've gone in and used a hardened case, and we also have a little strap that fits over top of it that clamps to the back of your hand. So you can use your Leica or your tape measure with one hand, and you can hold the thing in the other hand in most cases. About 10% of the time you actually have to lay it down to use 2 hands, but in most cases you can use it like this. The reason we're using Photo Measures is Photo Measures allows you to use one finger, or in this case you'll notice I'm using a stylus. With the other one you have to use 2 fingers and spread the lines apart, and I'll show you a little bit. This happens to be a screenshot of an iPad of a landing on a wood stair that we were taking measures off, and you'll see this is what's actually on the screen. This button allows you to take measures, and all you do is select it, drag it across. It leaves you an open place to key in whatever measurements you've got from your Leica or your tape measure or whatever. You can also put notes in. It allows you to put notes in. It allows you to actually check angles if you'd like to do that. You can highlight. You can do a lot of different things. Change the size. But this has turned into a real handy tool. If I had a full set of drawings from an architect, I probably would not use this unless I was taking some abnormal place, and you'll see one in a few minutes why I did it. But if I go out cold with nothing in front of me, nothing I've got, this is typically the way I'll start documenting, because what you remember is we typically come back and go ahead and write the dimensions on our pictures so the detailer can see both at the same time. This takes me a little extra long and a little extra time in the field, but I've skipped that whole step of coming back, printing the pictures, writing on them, and rescanning them. You've got this in your database right now. You just import it into your computer and you've got it. There's just one shot of an upper balcony area. You'll notice in this case we've actually measured the stair and we've inputted the measures. Then I came back in later and wrote in what the x-axis and the z-axis drop was on this. And I also, and so I don't get confused, I also know what flights these are. This is where I would use this unit even if I had a full set of measures, because what they were wanting us to do is hit this plinth block up at the top with the top rail. So we had to document exactly where that top plinth block is. So we did that with a measurement and measuring, and you'll notice there's also a little note that this border was out of square and they want us to follow the border. So with those notes and those pictures, we were able to convey to the detailer exactly what they needed to do. Any questions on measures or how we document or how we get it into the computers? Okay, we'll go through measurement procedures. We'll start with straight guardrails. These are pretty easy, pretty basic, but what we've started doing lately, especially if you have a tapered column, what we'll do is we'll actually measure up where we are going to hit. We'll put a small blue tape on it, and then we'll use our digital measuring machine just to measure across at that point. Then we also, in this case, we measure across the base to know what we need in the base. We started doing this more and more, and it depends on the quality of your contractor. We found we do get a lot of stucco walls. We found in stucco walls that a good contractor, that stucco wall is going to be really straight all the way down. But some of your third and fourth tier contractors, especially in commercial, the guys got a little sloppy at the bottom, so you'll find out that the bottom measure and the top measure might be a ½ inch more difference. So we've actually started going in and doing our primary measure at the height we're going to hit that rail at that point. We also, if you get out on the islands, there's got a technique out there which is really bizarre. It looks like they've floated bumps and humps in their walls. So you can measure a wall at one point and you measure a wall at another point and you'll get an inch difference. So we pretty much figure out where we're going to be from that point. And there again, you just have to gauge your contractor. Measure the slope. We would use a smart level between the columns in this case, but in this case, this one went all the way around from 3 sides. So we just set a rotary laser right in the middle of it, and we just used the rotary laser to go all the way around the balcony from that point and got our finished slope. But that's pretty much how we would do straight guardrails and balcony rails. I've got a question. I've got 2 questions. One, do you use email or transfer the files to the PC? We do sometimes. There's a product, and if you email me later, there's a product that will transfer directly from your iPad or your iPhone to your PC over the internet, which is much faster than sending emails. It's not dictated by how big your email is or how big your pictures are. It'll transfer it directly over, which is what we use now. I have another one. Do we use Dropbox? Dropbox worked great for that action. We use Dropbox. We use Box.com as our FTP site. When we're sending something out, whether our clients, they get all their pictures and they get all their dimensions and their detailed drawings. And it's difficult to send all their pictures to them on email, so we put them in the Box.com. Which is the same as Dropbox. They have their own file, they have their own security, they're the only ones that can see it along with us. And that they can go in and pull out whatever ones they want and go from that point. Tapered columns being out of Plum. We've got a question about that. These tapered columns are in Plum, but they are tapered. And remember what we did, remember the issue about The seamstress tape. First thing we do is wrap the seamstress tape around in several places to see whether it's consistent coming up and down. And then what we do is we take our smart level and lay against the column, and we would document what our smart level is showing us on the column all the way through. You'll see that anytime you're using your Leica or your Hilti or even your tape measure, you can pick up that they're not plumb. At that point, we switch to the smart level to tell us what we've got. Yes, box.com is correct. That is the one we use, and they give us about 5 gigabytes, which is more than enough for us, and it's free up to 5 gigabytes. Have you ever used a rangefinder and ended up with a product that would not fit? That's a really good question, and I would tell you that I'm a little bit anal, and even if I use a rangefinder, I will throw my tape measure on a few of the measurements to make sure that nothing's happened both with the rangefinder or with me. Also, if I'm shooting from column to column, I'll hit it twice. It's really quick. You push the button and it shows the red dot. You push the button, you got a reading. You push it again, you show the red dot, and you push it again, you got the reading. You got 2 readings. If they both come out the same, I'm happy. If they're both different, I try to find out what's going on and why I'm getting a different measure. In many cases, especially if you're using a distance meter on a tapered column or a curved column, it's real easy to get too high, too low, but both of these units have either a plumb level on them, or you can have the level of how you're holding it right on the screen, so you can tell if you're going flat. But there again, I've had problems. I've had more problems with the tape measures than I've had with these units. But like I say, you'll see this in the rest of the thing. I'm a little bit anal, so I'm a little cautious. So I always do double check measures, just to check myself. Straight stairs. Straight stairs are pretty much run-of-the-mill. What we do is, this just happens to be an example of one that we shot. They're putting an 1/8 inch coating on top. It was a commercial stair, so we went ahead and measured it up. What we do is we obviously do our length to angle. You typically with a tape measure and a smart level. Now it depends on what's happening with your treads, and typically what I'll do, the first thing I walk in on a stair is I'll take my combination square and I'll just walk up and down the risers and just hit some of the risers coming up and down. If I see that the risers are pretty consistent, then I know I've got a pretty good contractor, and it puts me at ease. If those risers, if that combination square is moving up and down and around, then I've got to take more measures. That's usually my clue and my quick check of just seeing what I've got in front of me. If it's contractors that I work with all the time or we know real well, then sometimes I don't measure at all. I don't worry about it. But we check our length to angle. The Leica D8 has the ability, if you put it on a tripod in the top, to shoot the bottom step and the nosing of the top step, and it can do the same measure and angle for you too. We would check the width of the stair. We would check a few of the rise and runs, and it depends on really what you're needing. If you're going to spindle embed, we would pretty much document rise and run all the way up and down the stair. If you're doing a straight stair with a bottom rail, we wouldn't necessarily check the rise and run on all of them. Number one, our smart level is going to tell us if there's something that looks weird, because it's going to rock when you put it on. Number two, what we do is we'll look and say, okay, let's, for example, I'm going to put a post on this stair. What I'll do is I'll put my Bosch laser at the top of the stair, and I'll let it run out here, and I'll do 2 things. I'll check the height from that laser line down to the nosing of the chair, and if I'm putting a post there, I'll also check this height right here so I know what that height is. It's real simple. It takes just a few seconds to do. But more importantly, before I walk out, before I go to the next stair run on that, I've taken this height measurement I get here, and I've taken the length and the angle, and I'll show you a little app that I use all the time. Before I walk away, this is my double check. If my math on my angle and my length and that height did not match up fairly closely, then I know I've got a problem. I've got to find out what's wrong with my measures. So right there is my double check. It can be their height. You can also shoot straight down, and you can do the height. You can do the distance this way. Whatever you need to get the 3 legs of that triangle, you can check that and make sure you're covered. And like I say, that's where I never walk away unless I've made sure I've covered myself on both cases. Same way, this happens to be a stair that we did E-template with, and we'll show you a little bit about E-template later because we had several questions in the last one come up. But same thing, rise and run, angle and length all the way down. On every one of these, I will check the angle and length to make sure my math works. The worst thing you can do is get back to your office and find out that you're off an inch or two on your math and your angle's not working. We will also heavily document all these transition areas. Remember, our issue is to try and give the fabricator as much information they can. We'll put those transition areas on AutoCAD. In a lot of cases, we'll print them out a full-scale template of that transition or gooseneck or whatever you've got there from both directions. So all they've got to do is follow what you put on CAD. This is something we do a lot of. Whenever we get in a transition area, or you'll notice this is really peculiar. This happened to be a landing where they had a notch out in front of it for some reason. They couldn't get the math to work. So what we do is we just take a piece of blue tape, a couple pieces of blue tape, and we'll lay on that transition area, and we'll do the measurements, and then we'll write right on that blue tape. And that way we know we've got not only the picture, but we've got some good measures on the blue tape. We know we can go back and pick it up. It takes just a couple of seconds, but we'll pretty much do this on every transition that we have. Here's another good thing. As I told you, I don't like to sketch, but I do if I have to. But this happens to be a piece of trim that was going to get in the way, so what we did is we went in and put a piece of blue tape down. I measured the height and the depth of the trim and threw my tape measure down and got the width of it, took a picture, and that was it. So we'll do a lot of that stuff if it's something minor, something we're not worried about, or a transition area, we'll do all that. I've got a question about the targets on the tread. Let me see if I can get back. Those are E-template targets, and give me a little bit and I'll show you a little bit about E-template. We had a lot of conversation last time, and I've added a little bit more in here about that. This is the app that I was talking about. This is on my iPhone. It's called Right Angle. It was it was less than $5. And with this, I can key in any two of these numbers. For example, if I check with my tape measure smart level, I can key in the length of the stair. I can key in the angle I got. And if my check measure does not come out fairly close, then I know I've got to go back and do some more work. Really, this is probably the #1 app that I use on my iPhone of all the apps I have. Engineer's Edge has another one, or like I say, if you're really smart, you can do a trig calculator, but this works better for me. Curved stairs. This is usually where we get a lot of questions about curved stairs and about how we do them. We've got a couple of basic premises on curved stairs. And our thought process is we're going to produce a full-size layout so somebody can pre-roll their top and bottom bars. We can tell them exactly, or as best as we can, what the radius is of their top and bottom bars as they would be laying on the stairs. And we do that as a prelude to going out and framing the stairs. We use Jack Klum's method of framing stairs. If you look into NOMMA, if you haven't seen it, he does a really good curved stair fabrication video. And we use basically the same thing where we go out and actually frame a curved stair. We even frame curved stairs out in the islands or in other locations. That's the process that works much better. But what our intention of doing is give that fabricator the curved bars before he ever goes out. And then all he's got to do is a little tweaking. Next, what we do is we produce our railings in flattened state. And we do that because we know in flattened state, It's dimensionally accurate. We've already covered in the office the 4 and 6 inch sphere codes. And also we have the ability at that point, we can full scale plot an entire stair if we need to. We have at times where a fabricator is struggling with it, and what they'll do is we'll take a piece of what we use down here is called thermoply. It's about 1/8 inch thick fiberboard, 4 by 8 sheets. We'll full scale plot it. They'll spray it with spray glue, and they'll paste the full scale plot right to that. They'll go up to their frame that's hanging up on a story pole. They'll go up to their frame, and they'll actually adhere the back of that thing to the back of their frame so they can stand it back and look at it and say, okay, here's what my stair should look like as we get done. Everything we're trying to do is trying to help the fabricator in the shop and trying to make their done, and then secondly, the installer in the field. Curved stairs. Typically curved stairs, and it depends on how many gyrations, and I'll show you the pros, the goods and the bad examples in a minute. This is a very nice stair. This happens to be a 3-story stair. It goes up 3 flights. It's got a nice curve. It's nice curve, goes to landings, goes to another curve, and goes on through. And this is the flattened out state of that curved stair all the way up through the 3rd flight, which you can't see. There's another landing above this, but this is the entire stair. 4-inch code is covered, 6-inch code is covered, so we know that the design and the stair geometry itself, we can cover all the codes that we need to. And to do this, the easiest way to do this, if you don't have a V-template or some of those, one of the easiest ways, the most accurate way we've found that we've checked this method with V-template is just get your old chord length and your radian and your total drop. You need about 3 measures, as that's considering your stair is in pretty good curve. So what you're looking for is the distance from this nosing to that nosing. And typically the problem with this method is it typically takes 2 people. If you're really good with a set of clamps or some tape, sometimes you can make it work with 1 person, but typically it will take 2 people. You need a string line or a laser line coming up this way, and then what you need to do is you need to measure from that line over to find your biggest point of this arc on your treads. And then also you take your laser line to the one we were talking about. It's got 3 here, almost 4, and it's got 3 definite ones here because it comes down, curves in, it curves out, and hits a wall about 4 inches behind the wall, and you notice step, and then I've got another one down here. So I've got 6 different places for this stair tread. But when you're done, the other thing we do when we're doing this is when we flatten out a stair, we flatten out the stair where the railing is going to be. So you'll see these blue pieces of tape. On each one of these blue pieces of tape, there's a mark from the side stair tread to the middle of that mark on how many inches out that we're going to put that stair. So when we flatten out a stair for AutoCAD, in AutoCAD or in SolidWorks, we'll flatten it out exactly where the railing is going to be, not where the nosing is, not where the side nosing is. It's right where that railing is going to be. And that will change what you're doing. You can see how this one gyrates from a radius that goes one way and a radius that goes the other way. And that's a flattened out stair. And you'll notice on this flattened out stair, let me see if I can draw this for you. You'll see a couple places right there, right in here, and then look right in here. Look at the difference in the lengths of these tread runs. And what that is that's where your stair is changing directions. That's why those tread runs are different lengths. And that's why it becomes important that if you've got something you're worried about, you look for the rise and run as you come down. But that's the piece that you're trying to convey to the guy. And you'll also see the transitions right here. See a transition right there and right in there. That's where we've had to take a quick turn. If we go back, that's this area right here, where we've had to come out and then take a quick turn and go the other way. Okay. Stem wall is the same process. A stem wall, you just measure across, measure out to either side, do the same process with the stem wall. It's exactly the same. Whether you're mounting on a stair or you're mounting on the stem wall, that's the best way. That's the best way and the most accurate way we've found. And like I say, we've checked this backs against each template, which is very accurate to get this. Things you want to watch out for. Remember I said you go up and down and do a little check with your combination square. When you see something like this, you want to look out. I didn't ask Tom Zusik about what he thought of this, but in many areas this would be rejected because you're not maintaining a consistent height with your stair. There was no way to maintain this. This was a mistake by the stair builder and the wall builder. You notice this wall kind of tilts the wrong way, and then all of a sudden takes a chute and shoots down. Those are the things you got to watch out for. When you see it like that, you just got to take more measures. First thing we did in this case, we went back to the contractor and said, hey, this isn't right, so I'll go ahead and do it, and let's go. Okay, go back to the three measures. We talked about the measures you need, the cord length. We call this a radian length. It's not really the radian. This is actually the radian, but that's what we call it. The radian length across, you try to find the biggest point in that. You want your total drop to know from here to here how big your drop is from this step to that step. You can use a string line with a level on it. You can use a laser level, whatever you need to do. You can also measure from this point down to the floor here, and then from that point to the floor there, and subtract it to. It's typically close enough to what you're going to do. If you have a railing on the other side, you want also need the fourth measure. You want the distance over to the wall at that point. Okay. Unfortunately, this is the formula to figure out what that tread, the radius is from here to here, the length and the radius at that point, which is, I couldn't remember it if I tried. So what we did is we did a little spreadsheet on Excel. We have an Excel spreadsheet that comes in, and we enter the cord length, the length from nose to nose. We enter the radian going across, and it tells us what the radius of the cord length is. And if you email me later, I'd be happy to share this with you. But I'll show you, let me show you the easier way to do it. See if I can get my AutoCAD over here. Just imagine I've got, this is the dimension I took across, and this is the dimension I took from that point. Let me go in and I'll show you the easier way to do that instead of messing with, you just do an arc and strike an arc. And right there you've got your arc length at that point, right at that point. Now let's just say you want to put your railing 4 inches in from that arc. You can strike an arc in here. Let me change the layer on that one so it sets to the side. Let's say, for example, you've got a 48-inch tread width. Strike an arc. If you want railing on that side, you can change it to a railing from that side. You can strike a line from here to here for your top nosing. And at this point, you've pretty much got what you need. This is the line that is right in the middle of where your railing is going to be, and it's telling you that it's 183.943 inches long. That's one of your primary measures you need. If you flatten this out, that's the length of your actual stair. That's one of the primary reasons you cannot use your smart level typically on a stair, on a curved stair. It's better on a wide radius like this, but you get on a small radius, if you're picking up 2 or 3 treads at the same time, you're not really getting a true angle at that point. If you take some little short piece and put that little angle cube on, you can go from one tread to the next tread. But this is an easier way to get your angle of what the real angle of that stair is going to be. When that's important is when you're trying to lay that out on CAD. I typically like the divide command. If you don't use this is a really good command. Let's say I've got 16 treads, I key and divide. I pick my number and I pick how many treads I've got, and it puts a dot point out there. If I want to do my outside one, I just do the same command. Tell it how many to divide it by, and I've got it. And at that point, I've got my treads. I can key them in all the way around. I've got my treads all the way around. And also, I know what the distance is going around. The other thing, if you have AutoCAD 2012 or later, they have an item called Path Array. And I'll show you a path array. You select which one to array. You select the path you want to take, and it does a preliminary for you. It changes to divide, and you have to key in this case, I have 16 treads. With this, you have to key in an extra one because it counts the first one. And it automatically goes in and arrays that around for you. Now what I've got is, if I want to, I can go into any of these treads and I can strike an arc. And I can quick measure that arc with a quick properties if I want to. Stop at. This is the actual height coming down. This number is the same number that I had back here in the length of that arc. And then what I've done to get ahead a little bit, I've put in a little stair tread, and I'll show you the path array, but you can do this with the divide command easily. But I select my object, I select my path, it goes ahead and throws a group in there, and I tell it what I want. I know I just need to trim it. I'd come in and take this off because this is my actual top landing. So I now have my stair tread already drawn for me. You can do it this way, or if you don't have the latest version, you can use a divide command. Divide command would be the same thing. Divide. Select your object to divide and key in how many you've got, and you'll see I put a point in there, and you can just copy another stair. And what you'll see is this line right here is the same as the center curve that goes around the stair. This happens to be the angle. So if you imagine treads coming off this thing going this way all the way through, this would be the inside rail of a tread. We also have gone in and put in the height from fall from top to bottom. We've gone into SolidWorks and made a program that does this for us. So we bring the dimensions out from before, the length of the arc, the diameter of the arc, and all that. And what we do is we come in and we will draw. In this case, it's a half. We put in a 1/2 by 1 flat bar, which you typically could be 1/2 by 1 1/2, 1/2 by 1, whatever you've got. Typically, you're going to roll for your stair, and we put it in dead level with the horizontal axis at this point. And then what we do, sorry, let me get the right version. Then what we do, and this is typically, if you roll it in your shop flat on the lay it flat on the floor, and then take it out on your stair and lay it down on your railing, what you're going to see is you're going to see this helix tilting back on you. And remember that what that's done is we've not put a pre-rolled helix into this thing. So what we've been able to do is simulate what's going on, and we can come in and tell you now what that helix needs to be. And you'll notice that this straightened out. And what that is, if I go back to the top one's dead level, this one's dead level. So we can pretty much tell the fabricator now, okay, before you leave the shop, you need to put a 26.1 degree, which is pretty fine, 26.1 degree helix in this thing from top to bottom. You segment it, you can do whatever you need to do, because that's what he's going to have to do out in the field. We find it easier to get it close in the shop than what in the field. And we've been testing this procedure for a while now, and we're pretty comfortable with it that we've been able to do that. And that was a combination of using 3D modeling and trying to make that happen. All right. Let me get out of this. Okay, any questions on that thus far? All right. Let's talk about alternatives. That's the basic procedure we would use on a curved stair if we were manually dimensioning it. We had a number of different topics come up about eTemplate photo. eLaser Pro was shown by eTemplate people at the show in Orlando. The Leica 3D Disto, which is the guts of the eLaser Pro, we saw at the Home Builder show in Orlando recently. And what happens is with the Leica 3D Disto, which is a laser similar to your distance laser meters like the D8, and it's set in a head, and it has the ability to look down, look up, and it rotates and knows where it's at all the time. So it can do point-to-point measurements pretty much similar to what the eTemplate photo is doing. But I'll show you a little bit of the eTemplate photo. I'll show you a little bit about the pros and cons of Laser Pro. And I'll show you some more importantly, I'll show you some eTemplate photo coming into AutoCAD and show you really what the real issue you need to watch out for and what you need to look at. This is an eTemplate shoot. What the eTemplate photo is, each one of these dots, you shoot this in 3 different directions from 3 different angles, and the computer can calculate where this dot is from 3 different directions, just like it's kind of like a GPS unit. So what it does, it comes in and says, okay, in the middle of this dot, there's a point at the middle of this dot. I know where it's at X, Y, and Z, 3 dimensions. It'll do that all along, and you'll notice this red thing down here. What this is a gauge bar. This is 46 inches from one end to that. The computer uses that to do its calibration from that point. We also, you'll see some on the wall. You'll see some so we can tell where the wall is and what's happening. We can do transoms with it. You can do transom with the eTemplate photo, but I don't think you can do it with the laser system because the laser is going to shoot right through this glass and you'll never see it. But with the eTemplate photo, these dots are exactly 4 inches of diameter. So if I put a point in this dot, all I've got to do is offset it out 2 inches and I know where that edge is. A lot of different uses. This eTemplate photo will work, but eLaser would not because we're actually picking up the edges around this. This is where we put in a door for a client and they did not want to take their old door out, or in a lot of cases pull their trim off to figure out where it was. So what we did is we templated exactly where the door jamb was. We just made the new door just exactly what it was before. Stair with a wall, we're putting a handrail up the wall and down the stair. The stair that you saw before, that was actually eTemplated, and you'll notice, like I said before, these dots are right in the middle of where we're going to put the railing. And eTemplate, the reason you see extra dots is eTemplate has the deal, you have to have 15 dots in every photo, and with every photo you try to cross together, you have to have at least 6 dots to the same place. So there's some rules you have to, there's a learning curve with eTemplate. This is a decagon where a client is putting a pergola all the way around this decagon, and it's extending out away from the decagon, so you want to know what these angles were and where they're at all the way around, and you'll see this is the eTemplate shoot around the decagon. The eLaser would work in this case. It works very similar, but the eLaser is pretty new. This is actually one of the stairs that you're going to see in just a few minutes in AutoCAD. You'll see all of the nosings. I know where the nosing is on the side and the face nosing. We know where this is. We also know where this wall is going to be at. So let me show you a little bit about what this looks like. Let me bring, I lost it. laser. But the other issue is, what are you going to do with this when you get it in the shop? Because there aren't many fab shops that can use 3D down on the floor. So what we use it for is to get very, very accurate measurements. Yeah. Got the same one, sorry. You switch to 3D modeling. Okay, this is the same top-down view. I can rotate this, maybe. Rotate it. It's the same issue. This is AutoCAD 3D. So you've got to be comfortable. The caution I always put in front of people, you've got to be really comfortable with being able to use 3D or somehow to use 3D if you're going to use this type of thing. Okay, any questions? We're running a little short on time. '3D modeling, we have a question. 3D modeling only cost effective when doing multiple curved stairs per year. No, it helps. We also use 3D modeling if we're designing, in other words, a door that we're doing custom items on, like rollers, or we use it for a lot for mechanical parts. If we're making a part where we're custom designing, like I say, a roller or a latch or something like that, we'll use 3D modeling to do that. And you can get 2D out of 3D. The other thing that you might want to be prepared for if you haven't already been hit is a lot of the architects, especially if you're getting into commercial, they're asking for 3D models on a lot of things. And what they're doing is they're using you to integrate it back into their system using either 3D AutoCAD or most frequently 3D Revit or some of the others. I would tell you SolidWorks is a completely different animal than the AutoCAD because it's not as intuitive as AutoCAD. It works a little bit different. Works off planes, whereas AutoCAD uses views. But 3D modeling is something that eventually, whether it's 3D modeling or line drawings, it's eventually going to come more and more. But you just need to be aware of it if you decide to jump into it. What I would suggest if you're looking at 3D modeling or eTemplate or eLaser is contact one of the firms that already has them and have them come out and shoot or draw something for you or shoot a project for you and give you the output and let you walk through that before you spend the money to buy the whole unit, because they are fairly expensive and there is a learning curve with that. There's ePhoto units here in Florida, there's Dallas, there's St. Louis, there's where else? Tulsa, there's one I believe in Arizona. There's a few around that people can get out and do them for you if you'd like. But that's what I'd suggest you do, is see how it works for you. It's very accurate. It really has helped us, especially if you think about it. When we went down to the islands, we've got 4 stairs to shoot. One person went down, shot all 4 stairs back, came back with all the measurements and never had to go back to do it. So it is extremely effective. The reason we jumped into it is for that reason. We were doing a lot of traveling, so we wanted to send one person. We wanted more accurate measures. So. Here SolidWorks is less accurate than Pro-E. Do architects specify which 3D software they want you to model in? Most architects now are telling you need to be in AutoCAD Revit, or building modeling, or in some cases AutoCAD 3D. You typically won't get an architect that's using a lot of Pro-E or a lot of SolidWorks. Those are mainly the machine shops and people who are designing hair dryers and those type of things. SolidWorks worked really good for us because that was our first jump into 3D, because I didn't like AutoCAD 3D at the time, but now we're getting a little bit more comfortable with it. So AutoCAD 3D would be fine. Anything else? Let me see. I think I missed a question. Any alternative methods for measuring the helix without 3D modeling? There's a couple of formulas, and I've got one. I'd be happy to send you. It's a plug-in SolidWorks or a plug-in Excel formula, and it'll get you fairly close, but you're still going to be off some. It's a complicated formula, and I've not run across anybody on listserv or anything else that's got a better way. We found this one to be really accurate, and it worked really quick for us. And it takes just a few minutes to do. Belk's asking, does this work with Tekla software? That I can't answer, Belk. I'm not sure. eTemplate and eLaser will go into IGES, AutoCAD, and a DXF. It exports a number of different ways. It goes into CATIA, which really is the base of eTemp of SolidWorks. But whether Tekla, I'm not positive. You could contact the eTemplate people and ask them that question. What is listserv? Listserv is about 200 members that is going to post this at some point.
Yeah, I'm hoping that the storm didn't mess up the recording.
The photos, Belk's asking, we get the photos emailed. Yeah, just send me your email address and I'll forward you whatever you want. You can have the whole PowerPoint presentation. I know Todd's going to put it up too.